Okay, so this is that question from WebAssign, and this is what I see is I see a two-way table, and I also see they're asking me for a chi-square, so I know this is a chi-square test, but it's not a goodness of fit test because it's a two-way table. I've got where I'm testing whether or not somebody got the flu is associated or dependent on whether or not they got the vaccination. So I see a two. So what I see here is I see a 2x2. I see a 2x2 table. So one of the calculators I've been pointing you to is this one here. And to use this calculator, I'm going to select 2x2, okay, and see how nice lights up the yellow ones. And then I'm going to type in the numbers 12, 36, and 788, and 1146 or 1164. And I'll calculate it. Then what's different about this one, see how that chi-square doesn't agree with WebAssign? We're looking at the Pearson. This is what Dr. Stevens is using. Pearson was a statistician that did a lot of studying around associations. The Pearson correlation coefficient, when we did in chapter 10, when we did the correlations and everything, and the regressions, that was his work. And he also did some more what happens when you have categorical variables, not quantitative variables. So that's the one. See how that one agrees? So if you're going to use that calculator, make sure you look there. And that's how you get that value. Now, what if you want to do this by hand with a formula? So here, let me pause this for a minute. And I'll pull up the formula so we see what we can do with that. So if we look at the formula in Dr. Stevens' textbook, we take the observed value minus the expected value, we square that difference, we divide it by the expected value, and then we find the sum for all these values. So how do you do all that by hand? Well, he walks you through some examples, and we can do this on paper. I'm going to help you set it up on a spreadsheet, okay? And I'll share the link to the spreadsheet. The calculator is a heck of a lot easier, I'll tell you that much, okay? So let's see, summary here. I've got a spreadsheet opened up. Let's see, let me get that set up for us. I'll pause this video and come back to it. Okay, now to get the expected, what we do is we do the row total times the column total divided by the table total. And that's how we get the cell, what we expected for the people that got the vaccine and got the flu, breakthrough cases, right? So what I'm gonna do with the spreadsheet is I'm gonna click on equals, I'm gonna click on the 48, times that by the 800, and then I'm going to divide that by that 2000. Okay, so that's what we'd expect to see if they're independent. Okay, so then I'll do the same thing. Now I'm going to do the same row. So now for the 36, I'm going to do 48 times the 1200 divided by the table total. Okay, and now I'll do the same thing for the 788. I'm going to do row total times column total divided by table total. And then I'll do the same thing for that last cell. So I'm going to do row total times column total divided by table total. Okay, so there's the observed. Now remember in the formula here, let me come back to that for a minute. On the formula, it says observed minus expected. So that's what I need to do next, okay? I'm going to do, so this is going to be the O minus the E part of this calculation. So I'm going to do the observed value minus the expected value. Okay, see, I'm not lining up the cells. This is, the 12 is how many people we saw that got the vaccine and got infected. That's the same thing with the 19.2. That's how many would expect. So I'll do that same thing. I'm going to do observed minus the expected. And that's for the people that got the vaccine and did not get infected. Now, this is the people that did not get the vaccine but got infected. So equals, I'm going to do that cell minus that cell. And this is how many people that did not get the vaccine did not get infected. Obviously not coronavirus, right? right, so now the formula says take those differences and square them. So I'm going to do O minus E and then raise those to the second power to square them. So equals this minus, so I'm going to know that I'm going to square that, sorry. I'm going to just square that value, raise it to the second power. Okay, notice it gets rid of all the negatives. And I'm going to do that same thing with this fill over trick. All right, I'm assuming you know it. I mean, otherwise you got to click and do it. So now the formula says take each of those squared values and divide them by the expected. So this is going to be the O minus the E squared divided by the expected. That's the next part of that formula. Whoops, let me change that back so it's minus, not underscore. Here we go. So I'm going to take those last values and divide those by the expected. So it's that divided by my expected. And see, I'm lining up the cells. And I'll do that same thing. I'll do equals, whoops, equals that squared difference. Come on, squared difference divided by the expected. And I'll do the same thing, equals that squared difference divided by the expected. And the same thing, equals that squared difference divided by the expected. All right. This looks huge. This one looks huge. Did I do that right? Because I know I'm supposed to get 4 point something. I'm already going to be over 4. Let me make sure I did that one right. Let's see. All right, that's that squared, yeah. And then what did I do here? Oh, I see. Observed minus expected. Observed minus expected. Okay, that's still big, isn't it? Let's see what I did. Row total times column total divided by table total. That's correct. Okay. Then observed minus expected. What did I do there? That's what I did wrong. I did this observed minus expected. There we go. There we go. Now that's looking more reasonable. Troubleshooting, huh? And now to get the chi-square test statistic, we got to find the sum. See, the formula says take the sum of all those square differences. So I'll write the word chi-square, just so you know. And then I'm going to do the sum of all those cells, and I'm hoping I get 4.61. And I do. Okay, so that's how you calculate this by hand. Obviously, the calculator is a lot easier, and I encourage you to do that. Okay, so that's how you get the test statistic for that problem.